So we're going to continue topic 6.13 on improper integrals, and this time we are going to evaluate example 9 here, which goes from 0 to infinity. So, but check this out. It looks like we're only infinite at one, or improper at one end, but look, it's at the 0 end, it is also going to infinity. So we were actually improper at both ends this time. So I am going to choose a convenient place to split this because we have to. I'm going to pick on 1, so I'm going to split it at 1. Because if I can't pick 0, I'm going to probably pick 1 because that's the next easiest number to deal with. So we have the integral from 0 to 1 of 1 over the square root of x plus 1 dx, plus the integral from 1 to infinity of 1 over the square root of x times x plus 1 dx. We're going to switch that into improper integrals. So the limit, as I'm going to go, a approaches 0 from the right side, from a to 1 of 1 over the square root of x times x plus 1 dx, plus the limit as b approaches infinity, from 1 to b of 1 over the square root of x times x plus 1 dx. All right, now we're going to go ahead and we're looking at a u substitution here. It's kind of a weird u substitution. Check this out. I am going to rewrite these x's. I am going to rewrite them as the square root of x squared. So once I have that, I'm going to use that as the u. So u equals the square root of x, which is the same as x to the 1/2 power. Therefore, du equals 1/2 x to the negative 1/2 dx, which means I have du equal to 1/2 1 over square root of x dx. I have that 1 over square root of x part. So the only piece I'm missing is the 1/2, but as I move that to the other side, I get 2 du equals 1 over square root of x dx. So I just need to add a 2 in front of these. I'm going to come and take that shortcut there. All right. I'm going to go ahead and show the u sub just because it's a trickier one. So the limit as a approaches 0 from the right of 2, the integral of 1 over u squared plus 1, because the du piece is this, du, technically from a to 1, plus the limit as b approaches infinity of 2 times u squared plus 1 with 1 on the top, and then the du is the 1 over square root of x dx. All right, we're going to go ahead and integrate. We know that that's the arctangent, so I end up with the limit as a approaches 0 from the right of 2. Arctangent is u, or a over 1, or a over a. No, a or u over a. So u over a is going to be, no, it's not. It's 1 over a. 1 over a is just going to be 1 over 1, or 2 over 1 in this case. Arctangent of u, which in this case our u is the square root of x. I'm just going to put in square root of x over the a, which is 1, from a to 1, and then we get the same integral on this one. So the 2 is still hanging out there. Arctangent of the square root of x from, oops, I missed my limits, didn't I? 1 to b. All right, we're going to go ahead and do our substituting in. So we've got the limit as a approaches 0 from the right of 2 arctangent of 1 minus 2 arctangent of a, plus the limit as b approaches infinity of 2 arctangent of the square root of b. I missed the square root on this, didn't I? Because the square root of 1 is 1. Square root of b minus 2 arctangent of the square root of 1 is 1. All right, so the arctangent of 1, oh, check this out though. I'm not going to do that quite yet. I'm going to go ahead and apply this 0 and this infinity and watch what happens. So I've got 2 arctangent of 1 minus 2 arctangent of the square root of 0 plus 2 arctangent of the square root of infinity minus 2 arctangent of 1. Check out what happened. arctangent of 1, 2, and they're going to, so look what's going to happen. We cancel. Yay. All right, arctangent of 0, we've seen a few times, is this 0 over 1 spot, so which is 0 radians. So that's going to be, because sine over cosine equals 0. So that's going to be 0 for that term. And this is just the arctangent of infinity. Sorry, not the arctangent of infinity. It's the arctangent of infinity is pi over 2. We multiply those, we end up with pi. So therefore, this one converges. And then you'll notice that there's also another special type of integral. We're not going to hit this one quite yet, but this is a special type of improper integral, and we do cover it more in Unit 10.